Everyone, today we will discuss few more problems on flexural strength of PSC members. Today's first problem: a post-tension bonded PSC beam of unsymmetrical T-section has a flange width of 1500 mm and thickness of flange is 200 mm. Thickness of the rib is 300 mm. The area of high tensile steel is 5000 mm square, located at an effective depth of 1800 mm. If the characteristic strength of the concrete and steel are 40 Newton per mm square and 1600 Newton per mm square respectively, calculate the flexural strength of T section. So here it is T section, it is given, and it is post tension bonded section, so it means bonded flanged section, that is case 2. Here first let us take down the given data. B, the width of flange it is 1500 and depth is 200 mm. Width of web is 300. Area of steel, pre-stressing steel is given, it is of 5000 mm square and effective depth is 1800 mm. FCK 40 Newton per mm square and FP 1600 Newton per mm square. So first we need to find out effective reinforcement ratio, that is APFP by BD FCK. So on substituting values we will get 0.074. So by using that value we need to find out FPU and XU by D value. So in right side you can observe in the screen, here effective reinforcement ratio is 0.074. so it lies between 0.05 and 0.1. so for both we have 1, it is bonded flanged section, remember that. So for effective reinforcement ratio of 0.074, it lies between 0.05 and 0.1. for both we have 1, so the value of FPU by 0.87 FP ratio will also be remain as 1 only. So simplifying we will get FPU value, that is 1392 Newton per mm square. So next, for the same effective reinforcement ratio for 0.05, it is post tensioning. So for 0.05 we have 0.109 and for 0.1 we have 0.217. On interpolating for 0.074 we will get 0.16084 as the XU by D ratio value. Then simplify, we will get XU value, it is 289.51, but the depth of the flange is 200 mm, so it means your neutral axis lies in the web, that is XU greater than DF. So next, what we need to do next, it is first we need to find out what is the reinforcement in the web and reinforcement in the flange. Then for reinforcement in the web we need to find out new effective reinforcement ratio, that is APF reinforcement, pre-stressing steel in flange 0.45 FCK into B minus BW into DF by FP. Substituting we will get 2700. Total steel is 5000 mm square. So in that if you subtract 2700 we will get area of steel in web section, that is 2300 mm square. So for that area of steel we need to find out new effective reinforcement ratio by considering web dimension, web width, APW FP by BW D FCK. On simplifying we will get 0.17. so again new value of FPU and XU by D we need to find out. So for 0.17 it lies between 0.15 and 0.2. For 0.15 For post tension it is 1.0, and for 0.20 it is 0.95. Remember, it is post tension member. On interpolating, for 0.17 we will get 0.98. On simplifying, we will get FPU as 1364.16 Newton per mm square. In the same way, for 0.15, XU by D ratio for post tension case, for 0.15 we have 0.316, and for 0.2 we have 0.414. So on interpolating for 0.17, we will get XU by D ratio as 0.3552. On simplifying, we will get XU 639.36 mm. Then by considering the moment equation, FPU APW into D minus 0.42 XU plus 0.45 FCK into B minus BW into D minus DF by 2. On substituting all the values, we will get 1.21 into 10 power 10 Newton mm, or you can write it in kilonewton meter also. Next problem, calculate the ultimate moment capacity of the pre-tensioned section of size 300 mm by 500 mm having an effective cover of 100 mm if FCK equals 42 Newton per mm square, FP 1900 Newton per mm square, and area of steel 600 mm square. So calculate ultimate moment capacity of pre-tensioned section of size 300 by 500. So pre-tension means it is a bonded section. Size of the section is 300 by 500 means obviously it is rectangular section. So bonded rectangular section. First step, again it is effective reinforcement ratio. We will get 0.226, table number 11. Remember, in question it is mentioned pre-tensioned, so you need to refer with pre-tensioning case. So for effective reinforcement ratio 0.226, it lies between 0.2 and 0.25. For both we have 1 for FPU by 0.87 FP ratio. So on simplifying, we will get FPU value as 1653 Newton per mm square. For next, XU by D ratio, for 0.2 we have 0.435. Remember, it is pre-tensioning, and for 0.25 it is 0.542. On interpolating, we will get XU by D ratio as 0.49064, XU value 196.256. So substituting in the equation moment M equals AP FPU into D minus 0.42 XU, we will get 314 into 314.97 into 10 power 6 Newton mm. Next problem, a pre-tensioned concrete girder of box section 1 meter by 1 meter overall dimension has a uniform wall thickness of 200 mm. The girder is pre-tensioned by high tensile wires of area 2250 mm square located at an effective depth of 900 mm. If FCK equals 40 Newton per mm square and FP 1600 Newton per mm square, calculate the ultimate flexure strength of the box girder section. See, here it is box girder and pre-tension. Box girder means it is a flanged section. Box girder will be considered as flanged section because there will be outer walls and inner hollow portion. So top and bottom wall will be considered as flanges and side walls will be considered as web. So here you can observe in the diagram, overall dimension of the box girder is 1 meter by 1 meter and thickness of the wall it is 200 all round, 200 mm all round. Effective depth 900 mm from the top. So width of the flange will be 1000 mm, depth of the effective depth will be 900 mm, thickness of the web is 200 mm, width of the web, you are having two webs, so you need to consider the total web thickness, the summation of both web thickness, that is 200 plus 200, that is 400 mm. Then area of steel 2250 FC key FP. So first step, again it is same, effective reinforcement ratio it is 0.1, you got exact value. For 0.1 again it is 1 only from table number 11. So FPU by 0.87 FP is equal to 1 ratio. By simplifying we will get 1392 Newton per mm square. Then for XU by D ratio for 0.1 it is pre-tensioning, remember that. For 0.1 we have 0.217. So on simplifying, XU value is 195.3 mm. So here it is less than thickness of the flange because it is 200 mm. The thickness of the flange is 200 mm and XU is 195.3. That means your neutral axis lies in the flange. So directly go for the moment equation. M equals FPU AP into D minus 0.42 XU. On substituting, we will get 2.56 into 10 power 9 Newton mm. Next problem, a double T section having a flange 1200 mm wide and 150 mm thick is pre-stressed by 4700 mm square of high tensile steel located at an effective depth of 1600 mm. The ribs have thickness of 150 mm each. If the cube strength of the concrete is 40 Newton per mm square and tensile strength of the steel is 1600 Newton per mm square, determine the flexural strength of double T girder using IS 1343 provisions. So here it is double T section means you are having two web sections with single flange. You can observe in the figure. So total width of the flange is given, it is 1200 mm. Thickness of the flange or depth of the flange is 150 mm and thickness of web is 150 mm. Effective depth you have 1600 mm. So again here you have two webs. So the web width you need to consider a summation of two webs. So that is 150 plus 150. It will be 300. So again first step, effective reinforcement ratio APFP by BDFCK. On simplifying we will get 0.0979. So for that we need to take FPU by 0.87 FP ratio. So since it is pre-tensioned, go with column number 2. For 0.0979 means it lies between 0.05 and 0.1. So for pre-tension for both values it is 1. So FPU by 0.87 FP value will be 1 only. On simplifying we will get FPU as 1392 Newton per mm square. And XU by D ratio For 0.05 in pre-tension column, that is column number 4, 0.05 we have 0.109, and for 0.1 we have 0.217. So for 0.0979 on interpolating we will get 0.212. On simplifying we will get XU as 339.2 mm. So depth of the flange is 150 mm. So from the equation we can say that neutral axis lies in the web. So calculate area of steel in the flange, APF, by using the equation. Then APW, that is reinforcement in the web section. Then new effective reinforcement ratio, APWFP by BWD FCK. Here BW we need to consider 300, that is the total width of webs, that is summation of two webs. 150 plus 150 it is 300, so we need to consider BW as 300. On simplifying we will get 0.265. so it lies between 0.25 and 0.3. so from column number 2, FPU by 0.87, FP ratio is 1 again. For both values we have 1 only, so directly we will get 1392 Newton per mm square. For XU by D ratio, for 0.25 in column number 4 we have 0.542, and for 0.3 we have 0.655. On interpolating it for 0.265 we will get 0.5759, and simplifying we will get XU as 921.44 mm. Then substitute in the equation for moment of resistance, and simplifying we will get 9.07 into 10 power 9 Newton mm. Next problem, a post-tensioned pre-stressed concrete T-beam with unbonded tendons is made up of flange 300 mm wide by 150 mm thick, and the thickness of rib is 150 mm. The beam is pre-stressed by 24 high tensile wires of 5 mm diameter with an effective stress of 65% of the ultimate tensile strength of wires. The wires are located at an effective depth of 320 mm. Loss ratio is 0.8. If FCK equals 56 Newton per mm square and FP 1650 Newton per mm square, estimate the flexural strength of the section assuming span to depth ratio of the beam as 20. So here it is given as post tension unbonded tendons, that means it is unbonded case, and here in question it is given T beam, it means flanged section. So unbonded flanged section, it is case number 4. The flange width it is 300 mm, flange thickness 150, web thickness 150. Here AP is not given, we need to find out. So area of steel, here it is given that the beam is pre-stressed by 24 high tensile wires of 5 mm diameter. So we need to find out the area. 24 into pi d square by 4, we will get 471.2 mm square. Then effective depth 320, FCK 56, FP 1650 Newton per mm square. So first step again it is same, effective reinforcement ratio and L by D ratio since it is unbounded case, but L by D ratio is directly given, it is 20. So directly you keep the value and calculate effective reinforcement ratio AP FPE by BD FCK. So FPE, effective stress, it is not given, we need to find out. In question he has mentioned effective stress of 65% of ultimate tensile strength of wires. So ultimate tensile strength is 1650 and effective stress is 0.65, and again loss ratio is also given. So 0.65% of 1650 you have applied. Again in among that 1650, 65% of 1650, 20% of stress is gone loss. So again loss ratio is 0.8. So we need to consider both 0.65 into 0.8 into 1650. So finally we will get 858 Newton per mm square, that is the stress, effective stress. FPE we need to consider that one, AP FPE by BD FCK. On substituting and simplifying the values we will get 0.075. So since it is unbounded case, we need to refer table number 12. So effective reinforcement ratio is 0.075. It lies between 0.05 and 0.1. L by D ratio is 20. So for FPU by FP ratio, we need to refer column number 3 for L by D ratio 20. So for 0.05 we have 1.32 and for 0.1 we have 1.26. On interpolating for 0.075 we will get FPU by FPE ratio as 1.29, and on simplifying we will get 1106.82 Newton mm square. Again for the same values we need to go for XU by D ratio. So you can see for 0.05 in column number 6 for XU by D ratio, for 0.05 we have 0.16 and for 0.1 we have 0.32. So on interpolating for 0.075 we will get XU by D ratio as 0.24, and on simplifying we will get 76.8. So thickness of the flange is 150 and XU by D, XU value is 76.8. so neutral axis lies in the flange. So directly we can go for the equation FPU AP into D minus 0.42 XU. On simplifying we will get 150.07 into 10 power 6 Newton mm or 150.07 kilonewton meter. So here the code book what we are referring is 1343 1980, it is not 2012. If you refer 1980 then only you can find table number 12. Thank you.